One of the largest hydrological reserves in Spain, Alcántara Reservoir, is located in the north of the province of Cáceres. It formed a natural obstacle to La Plata dual carriageway, and two singular bridges had to be built, one for each carriageway. The reservoir is crossed by 400-meter-long twin viaducts, each of them built with a 220-meter span central deck arch. Construction commenced by excavating the foundations, formed by reinforced concrete footings resting on micropiles, which, apart from transmitting vertical loads to the ground, contribute towards improving the stability meters maximum height, taking up a stepped shape where it makes contact with the ground. The vertical reinforcement anchorage of the tallest piers and the set of high-strength steel bars arranged in a sloping position to form the fixed attachment between the metal arch and the foundations are located in its inside. Each deck is built of two V-shaped Corten steel continuous beams joined by a top reinforced concrete slab. The slab is built on a 26-meter-long formwork tables, moving at the rate of one complete module a week, until the deck's overall length is completed. Dry land construction is performed in a simple fashion and enables the deck to be built under optimum accessibility conditions. A transverse beam is used to push each deck at the back where cables are applied to transmit the horizontal thrust force. The maneuver is carried out by sliding the deck over Teflon bearings placed on concrete blocks 15 meters from each other. The same launching operations and removal of the front metal part of the deck's main beams are repeated on the opposite bank of the river. Each arch is divided into 60-meter-long parts, weighing 200 tons, which are assembled horizontally and moved over the deck with skids up to the front part, where a metal gantry picks it up for the advancing, overturning, and lowering operations until connecting with the previously placed bottom piece. The gantry is fitted with moving elevation and retaining mechanisms, formed by hydraulic jacks operating vertically arranged cables. The next quarter archer is then carried over the deck until connecting with the previous part in an area provided with hinges. Quickly acting hydraulic jacks placed on deck-supported steel auxiliary towers are used instead of crane hoisting in order to control movements in the last phase when the second quarter of the arch is rotated. Fitted stops for obtaining a 3-hinged arch are arranged at the front of the semi-arches, and a stable structure independent of the holding cables is thus obtained. The sections are then completed with welded plates, and the hinges are locked. The hinge support structure is connected to a system of horizontal bars and jacks, controlling the displacement movement towards the reservoir, and each semi-arch's orientation, so that they both match up with each other at their front. Lowering operation has concluded. The hinges are locked by fitting anchor bars and reinforcements, followed by concreting the area where the rotation mechanisms have been housed. The bridge over the River Tagus is a national and a world landmark in arch building. Not only for its size, but for the combination of construction systems and auxiliary resources used. Operations involving deck launching, large part tilting and lowering, lifting and lotating a quarter of an arch, and finally semi-arch lowering were harmoniously linked, thus constituting in itself a world record, since operations of such a magnitude were unknown up